Cool, taking a look at a project by Anna, Battleship. There is a link to a demo. We have a human and a computer, and the computer totally dominates. Let's see if I can... Fun. A human has no chance. Let's take a look. So I create React app, deploy to GitHub pages. I like that we have a link to deployment here. Easy to play with. Let's take a look. I like having tests. Tests are great. So you have a ship, or you create a ship and then you ship the ship. And it's not sunk. Yeah, having tests is great. Let's look at the React app. So we have the header and the game. So there is the header, and then the game. When I see a lot of use states and some use effects to keep the states in sync, I think it could be a good idea to move this to a reducer. So I'm not sure if you have seen this before. React use reducer. Basically, it's a way to describe your state updates in one function. And then instead of having all these states as separate hooks, you have one state that represents everything. So in this case, you could have something like this. So the idea is that you have some state and an action, and then it returns new state. And then your initial state would be computer. So you need a computer. I'm not sure you need all of this stuff in the state, however, we're taking one step at a time. So I just removed all this, replaced all this state by use reducer. And now inside the reducer, what we can do is, so let's take a look how you dispatch. So handle click, for example. Oh, okay. So you have this function that represents event. So when the person clicks somewhere on the grid, I assume. And this is actually a good example of an action. So what you can do is you can say in your handle click, what you can do is dispatch an action with type click and then coordinates. Okay. And then in your reducer, you do if action type click. Then you can basically check all this. Make human move. So total score. Let's see. Cool, so I've tried to reduce this a little bit, but this is the idea. Instead of having all this logic here and changing individual parts of state independently using sets, what you can do is you can build this reducer function where it accepts the old state and an action, and then from that it produces the next state of your application. So in this case, for example, when we click, we can check all these things that you check in here, and then in your original code you call make human move that does some additional checks and then does some sets, right? What you can do is you can change it here, so you can return a new state where the computer turn is true and computer board is new board. Okay. The nice thing about this pattern is that all your state changes are encoded in this function, so you can unit test this. You would have some tests like handles click. What you can do is have some initial state, and then you can call your reducer with that initial state, and then action of type click with chords 0, 0, and then you can expect that this to equal some other thing. Okay, and you can make sure that your reducer is doing what you want it to do, and it all doesn't depend on the React at all. So it's just a pure function that takes state and produces the next state. And then thinking more about the functions that you have here, like handle click and stuff, or reset game, those can be actions that you can dispatch. So for example, in the reset game, it's when you close model. So you can do this, and you can just dispatch type reset, and then inside your reducer you can do like if action type is reset, then you return some initial state. One thing to note here is that in my code, in your code, every time this component renders, it's going to call this function. And if it's an expensive function, I'm not sure if it is, it does some loops. So probably not a big deal, but it recreates this thing over and over again every render, but it discards it because it only needs it for initial state. And to make it better, what you can do is use a function here. So when you do this, React is going to call this function only once, and then every time the component renders more, it's just going to use the cached version, and it's not going to recreate your board every time. Cool, let's take a look at what else is out there. So we looked at the header. The board is a React component that just renders with squares. Then you have a model and a player section, restart button. Pretty straightforward. Cool, this is where your main logic lives, I assume. Not sure what this does. It's kind of interesting. You stringify and parse it back, the adjusted coordinates. Yep, not sure. One last thing I kind of wanted to touch on is the usage of set timeout here. I think it's alright, but every time I see set timeout without clear timeout, it usually points to some memory leak, or it kind of means that you acquire this resource, you ask for a timeout, but there is no code that cleans it up in case it's no longer needed. In this case, it's not a big deal. This game section component lives throughout the lifetime of the app, but if you use it inside of some of the child components that are conditionally rendered, you might hit some memory leaks or some interesting edge cases and bugs. I think the way I would do it is that it's recommended to do these things in useEffect because it kind of synchronizes these external dependencies. So I would do set timeout function. I'm not sure what to put in here yet, but the nice thing about useEffect is that you can return the cleanup function. So I can say timeout is this, but then in case this needs to be cleaned up, you can do clear timeout. Okay, and then in here, what you can do is you can just dispatch an action that is type computer smooth or something like that. So now we need to figure out when to actually do this, and we can do this when the state comp move, is it comp turn, I see. If the state comp turn changes, and what you can do is if it's computer's turn, then you do this. So when it's computer turn, we use useEffect, and it installs this timeout and fires the event. And then when this changes, in case it didn't fire, React will clean it up. I think it's a fun little game. Thanks for sending. Hopefully some of these tips that I've talked to are useful, but kind of summarizing it, the main recommendation here is to replace a bunch of use states with a composed use reducer and encode your logic in a way that can be even further unit tested.